Hello, this is my second tutorial dedicated for MLOps. Check the first one and learn how to run Github Action to run your machine learning workflows by using Docker containers automatically. In this tutorial, let's talk about more complex situation. So let's the story begin. The main idea is realistic when you are working in the team on the same machine learning or deep learning project. Let's try to draw a simple scheme to illustrate this situation. Let's imagine you and your team is storing your model in GitHub repository. The repository has a master or main branch where the latest version of the model is available. To make it more self-explained, let's say a Spider-Man is that guy who is working on this branch. During the development, he achieved some metrics of the model. Let's say it's accuracy 1, accuracy 2, and accuracy 3. In meantime, for example, another team member is working on the same model as well. It is experiment branch, and for making it more fun, let the Batman to be the owner of this branch. And the Batman achieves other 3 metrics of the model with the improvement he made on the code. This video is focusing on this exactly realistic scenario and suggest an efficient solution how you can handle it. Problem that we need to solve in here is very simple. How to efficiently put all achieved metrics into one table intuitively when any change is being made on experiment branches if any of team members did it. To make it simple to illustrate, in this video we will limit the number of the team member, so the number of branches is 2. One for Spider-Man and one for Batman. So, in the result we expect to have this kind of table. This table must show values of metrics from all the branches in one place and calculate differences across the metrics in branches. This way of model performance tracking will save you a lot of time and efforts in model improvements and let you efficiently implement right decisions in development when multiple people work on that in multiple branches. Before switching off the slides, take a quick look into the machine learning pipeline we want to design. Pay extra attention to input and output for each Python script x1, x2, and x3. x1 is responsible to download data from external Google Cloud bucket. That is a train CSV and test CSV. Then x2 is taking these files and performs data cleaning and prepare data for the model. x3 is taking the processed data, train the model, and make the predictions. The result of the full pipeline is 2 files, metrics.json and roc.png. And metrics.json is the special one, because we will make a metrics comparison between this file across the GitHub branches. Let's go to hands-on and do it in real. Okay, and in the very beginning we have a very simple GitHub repository with one branch, and in this branch we are having 3 Python scripts. x1 is for getting data from external sources, x2 is processing the data and preparing for the model, x3 is model itself. We will make a prediction, we train the model, and on the top of that we are having a requirements file, and for our model we will use a NumPy, Pandas, scikit-learn, matplotlib, cborn, and wget. Okay, and before all the procedures, I have cloned this repository on my local machine, so it is a good time to do the same on your side, and keeping watching this video. Okay, remember the introduction part where I introduced the full machine learning pipeline for our project, and we had 3 stages for x1, for x2, and for x3, and now is a good time to be sure that all this pipeline is working. And for this I need to run x1, x2, and x3 sequentially in my local machine manually. So let's do this. I clean it up, and I just checking that I'm in correct directory. Okay, so I can run x1 is getting data, is running. Okay, then I have to check the outputs. Okay, I have a test CSV and train CSV. That's correct. Now I can run x2. Now we are processing the data. It's done. We have output is data processed.csv. So we are ready to go to X3. Python and X3. We are training the model and making predictions. Okay, and what will be the output of this? Remember the pipeline that I introduced in the beginning of this video. We expect to get roc.png file and some predictions in metrics.json file. So just wait a couple of minutes, I think in seconds. It is taking a little bit longer because it's making predictions and training, but it's not a problem. Okay, it's done, and let's check it what is inside. Okay, now we see that we got all outputs from each part, and we have a metric.json. Let's take a look in here. Okay, we are having accuracy 1, accuracy 2, accuracy 3, some metrics here, some metrics here. We have 1, 2, 3, 4, 5 different metrics as output, and this ROC PNG file. That's what we have expected to get. Now, in order to get further with this video and do the same steps as I will do, you need to install a DVC library on your local machine. And what is DVC? DVC is a special library that lets you work on continuous machine learning on your GitHub repository project. So let's go here, and you will see a special instructions for macOS, for Windows, and for Linux. All the procedures will be very similar in all the operation systems. In this video I am using a macOS, and please install it right now if you haven't installed it before. So that's it. So I'm closing this browser window, and remember when we run all the pipeline manually in terminal. So now we need to do the same but in DVC side. Okay, to do it I need to remove the outputs of the first run, and that's it. Yeah, I'm removing it. Okay, now I have the same structure as I had before, and now I know that this pipeline is working good. At the final I got a metrics and PNG file, that's correct. And now let's check how DVC run this pipeline as well. So let's come back to the terminal, clean it up, and first of all I need to turn on DVC engine. I need to initiate a DVC on this project. So I write DVC init, initialization of DVC. Yep. And now I need to define the first stage of my machine learning workflow and how I can do it. So please keep attention how to set up the first stage of our machine learning workflow. And now we will write complex terminal command to define the first stage. Okay. Yeah, it is DVC run. We define a new name for our stage, and the first stage will be let's say get data. We define dependencies. And what is dependencies of this stage? The dependency is x1 get data .py, and then we need to define the output. One output is train.csv, and the second output is test.csv. Okay, And then I am adding a flag that I don't want to execute this stage right now because it is only one of 3 stages. So I am not executing it right now. No executions. And then I need to run a Python x1 getData.py command. This is how I define the first stage in our machine learning workflow in DVC part. So run it. Okay, no errors in here. So now we can define a rest 2 stages in our workflow. Okay, now we have defined the first stage in our pipeline. Now we can continue to defining the rest 2 stages. So look, now we have a new file in our directory. It is a dvc.yaml file, and this is what we wrote in the terminal. It is information about the first stage. Remember, we wrote that we need to run x1 getData.py, dependency is xdata.py itself, and the output is test and train CSV files. So we can continue to append the stages in this file directly instead of writing complex command in terminal. So let's copy and paste this structure. Okay, and based on this structure, we can define the second stage, and let's name the second stage is process data. Okay, process, and for this we need to run this file. We are running Python x2 process data.py, and dependency, one of dependency is the Python script itself, and the second dependency is the output of the previous stage, because the stage number 2 is taking the output of stage number 1, and that's how it's working because it's a pipeline. And the output of stage number 2 is, we can check it directly in the code. Yeah, it is a data process.csv. Yeah. Yeah, data process.csv. Okay, now we have defined the stage number 1 in terminal, and we have defined the stage number 2 in YAML file directly. So let's finish with the last stage. Copy and paste the structure, and the last stage is train the model. Train. And for this, we will train, we'll call to x3. Okay, Python x3.py, and dependency, one of dependency is the file itself. So we copy and paste again in here. And what is our dependencies? It's the output of stage number 2. It is the same as we did before. The stage number 3 is taking the output of stage number 2 and do something with this. So copy and paste. Yeah. So stage number 3 is taking the output of stage number 2 and do something in here. And what is the output of stage number 3? Remember what we expect to get at the end. So it is roc.png. We can check it in the code. Yeah, we expect to get roc.png. And now it's very important moment. We need to define action what to do with the metrics files, because it's the special one. Because this file is a special one, and we need to tell the system that we need to compare metrics based on this file. So let's do it. Metrics. We tell the system that, hey, look at metrics.json. Look that this file is really exists in the code. Yeah, metrics.json. And now we have to tell the system that we can use different computers. And for example, now I'm using my laptop, but my team members can use different computers, or maybe I can use different computers by the end of the day. So I need to tell that we are not using a cache. So 1, 2, 3, 4, and cache equal to false. Okay, that's it. We have defined all three stages in our machine learning workflow. It is stage number 1, getting data. Stage number 2 is processing the data. Stage number 3 is training the model, sorry. And we have the output of our pipeline is roc.png and metrics file that is used for comparison of accuracies. That's it. So I'm saving. And now we have defined all the stages right now. Okay, and now is a good time to check how our workflow is working on DVC side. Look again at our directory. We have requirements x1, x2, x3, and DVC YAML file that define our stages. Okay, and I come back in my terminal, and now let's check how this pipeline will work on DVC side. So DVC and repro. Use DVC repro to reproduce the pipeline how it's working in DVC side. So that's it, and let's run it. Oh, okay, I got an error. It's about line 26. Okay, this is what I didn't expect to get. I missed this sign. Okay, saved again, and okay, do you see repro? Let's see what's happened. x1 is done, stage number 2 is done, and stage number 3 is running. It's running. Boom, and all the stages run successfully. Now we are sure that our workflow is working in simple way as well as in DVC side. Okay, now I know that it's working fine both in my local directory and in DVC side, and now I'm ready to push all this stuff inside my GitHub repository. Okay, let's do it. So okay, I clean it up. Okay, I clean it up, and okay, git add everything, git commit add everything for DVC. Okay, and git push. Okay, let's refresh the repository. Okay, looking good, and now we are ready to make some experiments in our branch, and now we need to define the GitHub action that we will do shortly. Okay, and let's do the GitHub action right now. Okay, this is also very important part, and we need to look at very strictly rules. We need to create a YAML file in very stable directory, and there's no space for interpretation. So we need to create a GitHub inside this folder we need to create another folder. It's workflows, and in here we need to create a train.yaml file. Okay, and what we need to write here in YAML file? For this we need to use a template from DVC, continuous machine learning, CML, and repo. Okay, and let's look in here, and here's the template that we need to use in our repository. I copy and paste only this part because what is below we'll write ourselves based on our project needs. So I copy and paste it right here. Okay, the name of our pipeline, let it be, let's say, classification testing pipeline. Okay, and this YAML file will create a Docker file that will run all the pipeline inside the Docker. So it's a very efficient way how we can to run machine learning workflows in a very efficient way. Okay, and what we have to change in here, we trigger the action on push event, so leave it as is it, and train my model. Okay, and first of all we install all the requirements from requirements file. Okay, and then we need to define what we need to do with our workflow. First of all, remember what we did firstly. We use a DVC repro to run all the pipeline inside the Docker. So DVC repro. So what we can to do next, we are using a special GitHub command, is GitHub fetch and prune, that will remove local remote tracking branches if they are not existing longer. Its simple works is collecting the garbage and cleaning up your repository, as you know. So we are using this command, git fetch prune, and then we need to tell the system that we are using metrics file for comparison, and we need to write it down in some user-friendly format, for example in readme file, in readme report. So DVC metrics different show flag in markdown in MD. Okay, we have which branch we are having. We are having the master branch. Now we need to define that we will make comparison of metrics based on the master data of master accuracies. So we use a master branch as the base of accuracies, and we write all this stuff in report.md. What we can do more in here, we can to add a figure into report. Remember, we have a roc.png that we can to add into our report. Echo. Let's make some headlines. ROC graph for the model. And we need to put ROC PNG below the table of accuracy. So we need to use this command, CML continuous machine learning publish roc.png. We write it in the markdown, and the name of markdown of readme file is report.md. Okay, we have defined what to do with this stuff in YAML file, and it is not all. We need to tell what to do with all this stuff. We need to deliver this information to team members that should be available in our GitHub environment. So it's a good idea to send it as comment in pull request section. You'll see it. Yes, I sending my report file as the comment in comment section, and this comment will be available for all team members. So I creating YAML file for GitHub action. Okay, and I committing into matter branch. Oh, okay, I see that I make a very stupid mistake in YAML file. I just removing this signed and commit it again. Commit again. Okay, that's it. Okay, and this is the first GitHub action made for this project. And let's have a simple situation. We are working on machine learning project, and we make changes in code all the time. And some changes make a positive impact on the accuracies, on the metrics, and some changes make a negative impact on the metrics. And when we are multiple team members and each team members work on his branch, we need to track the performance and we need to select the best combination of changes that should be delivered to production. And for example, I am working on my branch. For example, my branch is Vytautas. My name is Vytautas. And I creating this branch from the master. Okay, and then I make changes in this code. I make changes, for example, I change a test size from not 11, but let's say it's 25. Random state is, for example, this one, and then I need not 20 iteration in k-keyboard classifiers. I need, let's say, 35. Okay, I just putting the random changes in the code. Okay, and that's all. And this is my improvements. Okay, and I commit directly to my branch. Okay, I'm committing. Go to actions. Okay, and I see that I have a pull request from my branch. I'm creating a pull request in here. This branch has no conflicts. Some check haven't complete yet. Okay, I'm going to details. And I see that my GitHub action is running and the Docker container is being created. And let's wait and let's see what result I will achieve with my changes in code and how I can to compare metrics across the branches. So let's wait a little bit. Okay, I see that my GitHub action finished successfully without any errors. Cool, and let's see what I have in my improvements. Okay, and in here I see that the old metrics has values and new metrics on my experiment branch has its own values. And change is for some metrics is negative, but for some metrics is positive. And this is how I can to track the performance of a model, of a single model across different branches if we are working on improvements and multiple people working on this. So that's looking good, and you can make multiple branches, as many as you want, And let's check the email, and you should get an email notification about your GitHub action run successfully. That's it. Okay, I got the same message in my email. I see the same information, and that means whenever you can get notified about changes in the model in email directly. So it is very efficient way how you can to track performance of machine learning model or deep learning model. And I hope that you found useful in this video. If you have specific requirements, specific wishes, what you want to see next in this series for MLOps, so drop a comment. I will pay attention to your opinion, and then see you on the next video, and never stop learning. Bye bye.